Hi guys, welcome back to my channel. For today's video, we're going to have a summary on chapter 7, which is entitled IP addressing. So in this, addressing is a critical function of a network layer protocols. Addressing enables data communication between hosts, regardless of whether the hosts are on the same network or on different networks. Both Internet Protocol version 4 or IPv4 and Internet Protocol version 6 or IPv6 provide hierarchical hierarchical addressing for packets that carry data. Designing, implementing, and managing an effective IP addressing plan ensures that networks can operate effectively and efficiently. This chapter examines in detail the structure of IP addresses and their application to the construction and testing IP networks and subnetworks. So, in this chapter, we also study about the IPv4 addresses. Um, as you can see, there is an IPv4 addresses expressed in binary. And binary is a numbering system that consists of the numbers 0 and 1, called bits. In contrast, the decimal numbering system consists of 10 digits consisting of the numbers 0 to 9. Binary is important for us to understand because hosts, servers, and network devices use binary addressing. Especially, they used binary IPv4 addresses as shown in figure 1 to identify each other. Each addresses consists of a string of 32 bits divided into 4 sections called octets. Each octet contains 8 bits or 1 byte separated with a dot. For example, PC1 in the figure is assigned IPv4 address. Its default gateway address would be that of R1 gigabit Ethernet interface. Decimal to binary conversion examples. This is to help understand the process. Consider the IP address 192.168.11.10. Using the previously explained process, start with the binary expositional value table and the first decimal number 192. Network and host portions. Understanding binary notation is important when determining if two hosts are in the same network. Recall that an IPv4 address is an hierarchical address that is made up of a network portion and a host portion. Also, we study here in the chapter 7 the broadcast transmission. Broadcast traffic is used to send packets to all hosts in the network using the broadcast address for the network. With a broadcast, the packet contains a destination IPv4 address with all ones in the host portion. This means that all hosts on the local network will receive and look at the packet. Many network protocols, such as DHCP, use broadcast. Also, why we need the need for IPv6. IPv6 is designed to be the successor to IPv4. IPv6 has a larger 128-bit address space, providing for 340 undecillion addresses, that is the number 340, followed by 36 zeros, IPv6 address representation. IPv6 addresses are 128 bits in length and written as a string of hexadecimal values. Every 4 bits is represented by a single hexadecimal digit for a total of 32 hexadecimal values as shown in figure 1. IPv6 addresses are not case sensitive and can be written in either lowercase or uppercase. The first rule to help reduce the notation of IPv6 addresses is to omit any leading OS zeros in any 16-bit section or hex step. Also, we have IPv6 prefix length. Recall that the prefix of a network portion of an IPv4 address can be identified by a dotted decimal subnet mask or prefix length / notation. For example, an IPv4 address of 192.168.1.10 with dotted decimal subnet mask 255.255.255.0 is equivalent to 192.168.1.1024. Structure of an IPv6 global unicast address. Dynamic configuration, SLAAC, or stateless address auto-configuration, is a method that allows the device to obtain its prefix length, default gateway address, and other information for an IPv6 router without the use of the DHCPv6 server. And in this summary, to summarize this chapter 7 began with a look at the basics of the boot process of a Cisco router. Next, the initial configuration of a Cisco router from the system configuration dialog prompt was explored. Extended setup mode was used to assign the router its initial configuration parameters, including a host name, passwords, and interface IP address. Configuration from the iOS command line was looked at next, beginning with the process of logging into and out of a router. The differences between user and privilege exec mode was discussed, including how they can be identified by their associated command prompts. A look at the configuration files on a Cisco router outline the differences between the running configuration stored in RAM and the startup configuration stored in NVRAM. The syntax for the copy command was also looked at, including its use in saving the running configuration to the startup configuration. An overview of iOS shortcuts explained navigation techniques that can be used from the command line, as well as the use of truncated or shorthand commands. A look at the terminal history command explained how to change the buffer size or disable it within a session. So, that's all for this chapter. I hope that you understand, guys. Thank you for watching, and see you on my next video. And before you leave in my channel, please don't forget to subscribe and click the notification bell so that you will be updated on my other videos that will be uploaded. Bye, guys!